Welcome to Mikab Model College online tutorial. We hope at the end of this lesson, you will have acquired the expected learning outcome. Sit down and listen attentively as we introduce your subject teacher.
Welcome to chemistry class. I am Saliu Abdul Wahab, your chemistry teacher. In this lesson, we shall try as much as possible to attempt solving some problems on nuclear particles. Sometimes a knowledge that is not well gained as far as the nuclear particles are concerned may pose some problems. Now let us see some questions that will guide us in the course of this lesson. Question number 1. The mass number of an element is 31. Hearing the mass number alone, something should quickly come as an idea to you. Remember that the mass number is the sum of the protons and the neutron. The mass number of an element is 31, which means that in that 31, some are protons and some are neutrons. If its atomic number is 16, this is a clue telling you that the atomic number is 15. And of course, the idea in our previous lessons shows us that the number of protons is equal to the atomic number. On this note now, we should be able to quickly deduce the number of protons from that 31. What is the composition of A, the nucleus? B, what is the composition of its atom? The first question, A, what is the composition of the nucleus? What and what makes up the nucleus of that atom? Without wasting time, you know that the nucleus is made up of the protons and the neutrons, but then we don't know the numbers. Let us quickly deduce the number. By solution, the mass number of that atom is equal to 31, which is given in the question. The atomic number is 15, which is also given. And from our previous classes, we said that number of neutrons is equal to mass number minus atomic number. Therefore, number of neutrons now is equal to 31, which is given as the mass number, minus 15, which is also given as the atomic number, which also represents the number of protons. Therefore, number of neutrons now is equal to 31 minus 15, which gives us 16. Therefore, to answer that question, that what is the composition of the nucleus of that atom? The composition of the nucleus of the atom is 15 protons and 16 neutrons. Sum up the protons and the neutrons to give you 31 as the atomic mass. 15 protons and 16 neutrons. To answer the second part of the question, B, that is, what is the composition of the nucleus of that atom? We have done that. The composition of that atom itself. Remember that an atom is made up of 3 subatomic particles, which we denote as PEM: proton, electrons, and neutrons. Having seen that the number of protons is 15, the number of electrons is 16, but we need to understand that the number of protons must be equal to number of electrons for an atom to be electrically neutral. Therefore, number of electrons is equal to 15, which is the same as the number of protons. Number of protons is equal to number of electrons, that we know. Therefore, the composition of the atom as a whole, no longer the nucleus alone, the composition of the atom as a whole is 15 protons, 15 electrons, and 16 neutrons. From here we can deduce the mass number as number of protons plus number of neutrons, which is 15 plus 16, and that gives us the atomic mass 31. And the number of protons we can also deduce from the question as 15. I hope you understand. But please, as a way of exercise, do try subsequently some other elements on your own. Question number 2. An atom with 17 protons, 17 electrons, and 18 neutrons has a mass number of dash. What is the mass number? By solution, we know that the number of protons is equal to 17, which is given. The number of electrons, which is also 17, given. And even if it is not given, we know that the number of protons equals to the number of electrons for an atom to be electrically neutral. Number of neutrons is equal to 18, also given. Therefore, mass number is equal to number of protons plus number of neutrons. And what is the number of protons? 17. What is the number of neutrons? 18. Mass number, therefore, is equal to 17 plus 18. And the mass number is equal to 35. The mass number of such an atom is equal to 35. Question number 3. If an atom of an element is represented as W with an atomic mass of 40, an atomic number of 20, determine its number of neutrons. As a way of solution, we know that the mass number is equal to 40 given. Atomic number equal to 20 also given. Also remember that the atomic number is equal to the number of electrons. Therefore, mass number is equal to number of protons plus number of neutrons. Number of protons is 20. Number of neutrons we don't know. Hence, we must look for it. To deduce the number of neutrons now, we say that number of neutrons is equal to the difference in the mass number and the number of protons. That is mass number minus number of protons. And what is the mass number? 40. What is the atomic number, which is the number of protons? 20. Number of neutrons now is equal to 40 minus 20. Therefore, this atom has 20 neutrons. It has 20 neutrons, and then it has 20 protons, and then it has an atomic mass of 40. Sometimes the atomic mass of an atom, when you deduce the number of protons and the number of neutrons, may be equal. The number of protons and the number of neutrons may be equal, as in this case. This element can be calcium. Calcium, which is number 20 in the periodic table, has an atomic mass 40, an atomic number of 20. Number of protons 20, number of neutrons 20. Now, as a way of assignment, on your own, try and look at the elements on this table. The elements are assumed elements. the assumed atoms. An atom of element Y with mass number 40 and atomic number 19. Deduce the mass number, the number of protons, the number of neutrons, and the number of electrons. Remember, mass number is equal to atomic mass minus number of protons. Atomic mass is equal to number of protons plus number of neutrons, which is 40. Then the number of neutrons now is equal to atomic mass minus number of protons, which will give us the number of neutrons. And the number of electrons is also equal to the number of protons. The same thing applicable to atom of an element T, with 12 as mass number and 6 as atomic mass. Deduce the mass number, number of protons, number of neutrons, and number of electrons. W with mass number 39, atomic number 19. Mass number now is given, atomic number is also given. You can always look for the number of protons, the number of neutrons, and the number of electrons. In our next class, we shall be looking more of how these atoms do react and how these atoms exist, either in isotopic form or in non-isotopic form. Don't forget to subscribe to our channel. Thank you very much.